let's dive in. Today we're looking at Dragonfly, specifically version 2.2.0. And no, we're not talking about the insect. This Dragonfly is software, open source, and it's all about making file sharing crazy fast, especially for those massive files. You know, the ones that make you wonder if your internet's even working.
Exactly. Dragonfly uses a peer-to-peer approach to distribute files, P2P. Like those old file sharing networks, but way more sophisticated, built to handle the huge data demands we have these days.
Got it. So instead of everyone trying to download from one place, Dragonfly creates a network where everyone shares, and that speeds things up big time. This new version is getting a lot of attention for how it accelerates image sharing. Images are everywhere now, but what makes this so important?
Well, think about AI and machine learning. Those algorithms need tons of data to learn, and a lot of it is images. Moving all that data around fast is a huge challenge. That's where Dragonfly comes in.
Makes sense. Like taking the express lane for data. I can see why developers are excited. This version, 2.2.0, has a lot of new features. One that caught my eye is the switch to a Rust-based client. I've heard about Rust, but what's the benefit for people actually using Dragonfly?
Rust is known for its speed and security. It's designed to prevent certain kinds of errors, like buffer overflows. Those are often the cause of crashes and slowdowns.
Ah, so it's faster and less likely to have those annoying interruptions, like a tune-up and a safety check. I also see there's new bandwidth controls and a leeching mode. Leeching mode sounds kind of, well, maybe not the best way to put it.
Yeah, leeching has kind of a negative connotation.
Yeah.
But it can be practical. Say you have a limited data plan, or you just need to get a file fast and don't have time to share back. That's when leeching mode comes in. And the bandwidth controls let you limit how much of your connection Dragonfly can use.
So it's about giving users more control over how Dragonfly interacts with their network. Makes sense. Another cool thing is the optimization for small files. Anyone who's ever tried to transfer a folder with a ton of tiny files knows how slow that can be compared to moving one big file. Why is this optimization such a big deal for Dragonfly?
You're so right. Transferring lots of small files is super inefficient. This is really helpful for a system called Nidus. It's used to distribute container images. Nidus transfers a bunch of small layers that make up an image, and Dragonfly's optimization makes that process a lot faster.
I'm noticing a theme. Speed, efficiency, optimization. Dragonfly is all about getting rid of those wait times. Those wait times we've just accepted as part of moving lots of data. Speaking of speed, the new P2P protocol. This seems like more than just a small update. What makes it so special?
Well, it's interesting because this is actually their second version of the P2P protocol. They took what they learned from the first one, looked at how people were using it, and made a bunch of improvements. This new protocol, it's designed to be even better, more efficient, more reliable, so you get a faster and smoother experience when you're transferring files.
So it's not just speed, it's about making sure those transfers don't get interrupted. Dragonfly is getting smarter with each version. That's pretty cool. Now let's talk about how Dragonfly works with other tools. The article mentions Harbor. It's this popular platform for storing and sharing software, and it seems like Dragonfly makes it even better. Can you tell us more about that?
Sure. So Harbor is like a central hub for software, images, and packages. It's like a secure library where teams can keep their software components, manage them, and share them with others. And Dragonfly comes in by making it much faster to distribute those images, especially through this process called preheating.
Preheating. Okay. I'm trying to picture what that means in this context. Is it like preheating an oven?
It's a good analogy. Think about it this way. You wake up in the morning and your coffee is already brewed. You don't have to wait, it's ready to go. That's kind of what preheating does with Harbor and Dragonfly. It makes sure that the software images people use a lot are already available on the network. So when a developer needs one, it's already there, cached and ready to go. It makes deployments much faster and smoother.
So it's all about saving time and making the whole process more efficient. I see there are also new preheating options in Dragonfly 2.2.0. What's changed, and how does it give users more control?
With these new options, users can be very specific about how preheating works. They can decide which computers in the network take part in preheating, and they can choose which Dragonfly clusters to use. This level of control is important for organizations with complex networks, or if they have specific security rules they need to follow.
It sounds like they're trying to make sure Dragonfly works for lots of different types of users and situations. Now, I know Dragonfly isn't the only tool out there for optimizing file transfers. The article mentions BitTorrent, JFrog Artifactory, FastDFS, and Amazon S3 transfer acceleration. So how do these stack up against Dragonfly? Are there times when one might be a better choice?
You're right, there's no single perfect solution. Each of these has its own strengths and weaknesses. For example, BitTorrent. It's been around for a while and it's great at distributing large files, but it's not really made for software distribution. It doesn't have the same features Dragonfly has for handling container images.
So it's good for general file sharing, but not the best for software development. What about JFrog Artifactory? How does that compare?
JFrog Artifactory is more than just file sharing. It has advanced features like caching, security scanning, and build integration. It's a really comprehensive tool for managing software throughout its entire lifecycle. But it might be too much for someone who just needs to move big data sets or images around quickly.
So it depends on what you need the tool for. What about those other two? FastDFS and Amazon S3 transfer acceleration. What are their pros and cons compared to Dragonfly?
FastDFS is a really lightweight system. It's designed for managing and syncing files, especially good with small files. Really fast and efficient. But its focus isn't on accelerating container images, which is where Dragonfly really shines.
So FastDFS might be a good choice if you're working with lots of small files, but not necessarily the best for software development or containerization. And what about Amazon S3 transfer acceleration? That sounds like it could be a strong contender.
It is. It's a service from Amazon Web Services, AWS. It uses their global network to speed up transfers of large files. Really powerful, especially if you're already using a lot of AWS services. But it might not be the most affordable or flexible option for everyone.
I see. So the best tool really depends on your specific needs and what's most important to you. We've covered a lot today: peer-to-peer networks, image optimization, preheating, and we even looked at some alternatives to Dragonfly. What are the main things our listeners should remember from all of this?
I think the biggest takeaway is that tools like Dragonfly are becoming essential. We're dealing with larger and larger data sets and software packages all the time, whether it's software development, AI, machine learning, or any field that needs to move lots of data quickly. Dragonfly helps solve a major bottleneck.
So Dragonfly could really change how we work with data in the future. Beyond the technical details, what does the rise of tools like this tell us about the bigger picture?
It's an interesting question. Will tools like Dragonfly that focus on peer-to-peer sharing become as common as cloud storage is now? Will we get to a point where P2P transfer is just built into everything we do, like something we don't even think about?
It's something to think about. We rely on fast data transfer almost as much as we rely on electricity or water, and that need is only going to grow stronger as AI and machine learning become even more advanced.
Imagine downloading a huge data set or a complicated piece of software, and it's practically instant, thanks to peer-to-peer networking. No more waiting, no more staring at progress bars.
I like the sound of that. It's exciting to think about how Dragonfly could change the way we work and share information. If any of our listeners are interested in learning more about Dragonfly, we encourage you to check out their website, read their documentation, see how this technology might be useful for you.
Maybe you'll even be inspired to contribute to the project or come up with the next big thing in peer-to-peer file sharing.
That's great. Thanks for joining us for this deep dive into the world of Dragonfly. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.